number 84. The title is Concept of a Robot-Assisted On-Site Deconstruction Approach for Reusing Concrete Walls. So, Hyunju, the floor is yours.
Okay, thanks. I'm Joo, working as a PhD student at the Chair of Individualized Production in RWTH, Aachen University. And this presentation is about the concept of a robot-assisted on-site deconstruction approach. Yes. So why are we even concerned about deconstruction would be the first question. Actually, construction and demolition waste is one of most voluminous waste streams generated in Europe. As one can see in these figures, about 30% of all the waste comes from construction and demolition sector. So moreover, most of this waste consists of valuable metal and mineral waste, such as concrete and ceramics. This is already a huge problem, but the bigger problem is that the waste is growing with the time and is also expected to grow more in the future, since almost 2/3 of all in-use material stock will be aged 50 years by 2030. So they will reach the end of their lifetime in the upcoming decade. But currently, if people talk about deconstruction, people think of these activities in this video. So after removing all valuable materials, a huge excavator comes and crashes the building into small pieces. Of course, these crashed concrete parts are recycled somehow, for example, in the production process of highways. But this also involves then again downcycling and upcycling with a lot of energy loss. So the question that we had was, can we cut these concrete walls more precisely so that we could maximize the potential reuse? Yes, we can. Currently, there are different systems, from the manually guided saw machine to the teleoperated machine with a saw as an end effector available in the market. But the common problem is that the required effort to precisely cut these concrete elements is so high, so that just buying the concretes new or fresh are more cheaper. Also, you can notice in these images that a human operator is always on site at the workspace. So the task is also very dangerous for human operators. So our goal is to develop a deconstruction robotic system, which can automatically cut these elements from an existing building in a more controlled way to maximize the reuse potential. For this, our idea is to further develop a teleoperated machine into an automated machine so that the motion of this machine can be precisely programmed and pre-planned. So these teleoperated machines are actually great. They are exactly designed for these deconstruction activities. So they are mechanically very robust. The system is driven by hydraulic, so the payload is much higher compared to the industrial robots. So these are actually huge benefits taking this machine as a base system for our envisioned deconstruction robot. Of course, there are a few necessary adaptations that have to be done from the hardware and software side. For example, this type of machine are not equipped with any motion sensors, as they are designed to be directly controlled by human operators. So we had to attach rotary encoders for each axis to get a feedback from our command signals. But in this way, we were able to develop a semi-automated robotic system in our previous work. Basically, if the operator defines the desired goal of the hammer by moving and positioning this gray dummy hammer in the visualization software, the corresponding motion is pre-planned and visualized to the operator before execution. And once the human operator says, okay, this is what I want, then the planned motion is then actually executed. So right now, in this video, the human operator has defined the desired goal of the hammer pose. So the planned motion is then visualized to the operator. He has accepted it, so the motion is then executed. So by having the human operator always in the loop, for example, in the planning and execution step, we can now combine the ability from the human operators to think and decide, and the ability from the robot, which is the precision. But this is not enough. Imagining we have now a saw as the end effector for cutting tasks. We need another subsystem which can stabilize the cut element during the cutting task so that it does not fall down to the robot or to the ground. For this so-called subsystem, we will have either a tower crane or another hydraulic machine, depending on the local working environment. Yes. So also the aimed cutting task itself is a little bit tricky with this kind of machine. As visualized in the figure, a certain amount of force has to be applied orthogonal to the wall so that the element can be actually cut. But as this type of machine only rotates around one axis, we need another degree of freedom at the end effector, as visualized in the right video here, to ensure the orthogonal force to the element. Yes. And also from the software side, from the control side, further research must be also ensured. We talk about precise cut, but how precise does the cut have to be is the question. Here, according to the German regulation, the deviation must be smaller than 12 millimeter. And in our previous work, we have achieved between 1 and 2 centimeter error for point-to-point movement with this robot. So we are already slightly above the allowed error, but this 1 to 2 centimeter is just the error coming from the hydraulic manipulator, mostly due to the non-linearity in the hydraulic system. So later on, we will have more error coming from the vision system. So here also more work is planned. Yeah. For our final demonstrator, we will apply to the top-down approach in case the roof is still there. No, in case the roof is already removed, a crane can be used then as the subsystem to stabilize the cut element. Otherwise, if the roof is still there or the working environment does not allow the crane deployment, another deconstruction robot will then be used. But as a first step, we built a test stand where different types of concrete walls can be placed. This setup will then be used for our first experiment, where a desired geometry of the cut element is defined by the operator and the robot defines the cut sequence. Yes, this is of course just one more step towards the selected deconstruction. Assuming we manage to selectively deconstruct the elements from the building with our robot, still there is no market for this cut element. And these elements have to be controlled afresh, whether they are actually eligible for reuse. And this process costs a lot, so that just buying new things is just cheaper. But our hope is then to contribute a small amount to the circular economy with this deconstruction robot. Thanks.
Thank you, Joo Lee, very much for your very interesting presentation. Before move to the audience, I would like to ask a couple of questions for you, just to warm up. So basically, I see your solution, specifically cutting the walls and using crane system, and also this robot you developed. And so question one is that what about these peripheral corners or these type of places in the building, and also including the floors and this type of thing? So is your system only working on the wall panels? This is the first question. And the second question is, could you estimate in an ideal situation how much percentage of walls or how much percentage of concrete you can recycle using this method? Thank you.
These are just warm-up questions. Okay.
Yes.
As we have visualized in this image, we are actually just concerning currently just the upper side of the walls. So we are probably not going to aim to recycle the wall 100%, but from this wall, there will be a desired geometry from the human operators. Okay, if my wall is like 3 meter deep, I want to have a shape of, I want to have a geometry in the shape of like this, and this shape will be like 2 meter or 1 meter. Okay. And the robot will be then in the position to define, okay, from this given 3 meter to have 1 meter, 2 meters shape, it will be this ideal cut sequence that needs to be performed. So we are actually not concerning about the corners of the walls. Yeah.
Okay, thank you. Thank you for your answer. So I would like to ask the auditorium if there's any questions in the audience. We can have maybe one question.
Hi, can you hear me?
Yes.
Okay, thank you for the presentation. I have a question about the sensors, because you say that in order to replace the human being, you have to put some sensors. So which kind of sensors? And in your opinion, how much it will cost the final prototype?
Yes, we can go back to the slide again. So currently this robot is then equipped with encoders for each axis. And additionally, we have also attached 3D LiDAR for the environment perception. The costs, well, I have bought this through our university account, so it will be a little bit cheaper than usual price. But for each encoder, we have paid 300. So the machine has 5 axes, so we have paid 5,500 for the encoders, and for the LiDARs around 20,000. Yes.
All right. Thank you very much for your presentation. Again, I think we need to move on due to time constraint. Thank you. And then the next